Okay, so problem 1 on Dunwoody Mechanical Engineering heat transfer, course number 3250 from exam 1 in fall 2018. So we're given a description here. We're looking for the heat transfer processes for asphalt pavement on a hot, clear summer day. Let's try and give a hint there. We have direct sunlight. Ask for a little sketch of the system and label the heat flows for each process. I'm looking for at least 4 heat rates. Then we're looking for the equation for each of the heat rates and an energy balance for the surface. So let me start with try to get a little 3D here. So here's our road asphalt surface. Somewhere up here, got the sun beating down. So we got, oh, that one kind of got crazy. Q rad from the sun that gets absorbed into the asphalt equals alpha sigma T sun to the 4th minus T surface to the 4th. So that's one process. Also, there's some surroundings here. Maybe there's a tree, like a happy tree over here. Not Bob Ross. Wasn't obvious before. Now you can tell I'm not Bob Ross. So we've got radiation going from that to the surroundings. Q rad. This one's going to be emitted epsilon sigma Ts to the 4th minus T surface or surroundings to the 4th. That's the second one. We also have some air flowing here. So we have T infinity H. I'll call it H infinity. So we have Q convection, H A delta T, or we can add some more definition to that. We can have Ts minus T infinity. I'm assuming that the air is cooler than our surface temperature. And then we have some heat transfer into the surface of the asphalt, or into the body of the asphalt, if you will. So we're going to have some conduction. It's going to be negative K A T surface minus T. I'm going to use T soil. It's not really soil, but we'll call that over dx. So in the x direction, or my thickness. So maybe we'll call that L of that value. So those are our 4 heat rates. Got an equation for each heat rate. Now we need to write energy balance for this. You may recall using our E dot notation, we have E dot in minus E dot out equals E dot stored. So what do we have flowing in here? Got Q rad. So one thing flowing in, what's going out? Minus Q convection minus Q rad, let me call it 2 maybe, minus Q conduction. And what does that equal? It's going to get us our rho Cp dt, or our storage term here, that how our temperature changes with that. So I wasn't exactly looking for this in great detail, but I wanted to be convinced that you saw there were 4 heat transfer processes, or 4 heat rates, and how those impacted. And this is probably not steady state, so we want to include this term. It might be steady state, and this dt goes to 0, and it is all gone. So that's what we are looking for in problem 1.